Hello, you are listening to the Modern Web Podcast, where we explore next generation frameworks, standards, and techniques. I'm Tracy Lee at Lady Lead on Twitter, and you can find us online at modern-web.org. Hi, and welcome to this episode of the Modern Web Podcast. Today we are talking about WebAssembly with some awesome people. Yes, very excited people with facial hair. Sorry, Ben, to not include you in that comment.
I'm not very excited, so it wouldn't have included me anyway.
So we have Sean Larkin, who is on the Webpack core team. Hi, Sean.
Hey, how's it going?
You can find him on Twitter at the Larkin. We have Jay Phelps here, who is a compiler and other type of freak.
I'm a compiler. I am a compiler. Hi, everyone.
Yes. Yes, you can follow Jay on Twitter at _Jay Phelps. And then we have Ben Lesh here, who loves build processes.
I hate them.
Yeah,
I do.
But he loves facial hair, which is why he's on this, because he's trying to inspire.
Because this is audio, right? So this is audio only. And the thing is that Jay Phelps, like seemingly overnight, grew a more luxurious beard than I think Sean Larkin could ever hope to grow. I'm sorry, Sean. No. Like if you had Velcro on a ceiling, you could press Jay's cheek to it and he would stick.
Yeah.
Like it's really thick.
Industrial strength Velcro.
I like to stroke the beard.
Let's do that. That should be the next project. Like instead of those things, you know how you get into those suits and you Velcro and you jump? Jay could just jump with his face.
That would not work. Wait, what are we talking about today? WebAssembly?
Yeah.
Yes.
Yep.
So who wants to start? I think, Jay, you have some things teed up.
I do. I do? Question mark?
Yes. You always have things teed up.
Can we start with,
rambling
how about if we lead in with this? Let's lead in with the beginner thing. What in the world is WebAssembly?
Sure. Yeah. I can hit that. So it's like, imagine most of you probably listening at least know that a lot of programming languages have been compiling to JavaScript because they, like, if you want to write Elm or you want to write TypeScript even, or all these other languages, if they want to run on a browser, the only solution is to compile to TypeScript, or compile to JavaScript. Well, now the browser vendors have all come together for the first time and created this standard binary format, this compilation target for browsers. It's a bytecode. It really is. And so these compilers can now target this bytecode, and it's much more size efficient. The performance is much better than running in something like JavaScript. And things are rapidly progressing. It's going to enable some things that were not possible before. True multi-threading, SIMD, all sorts of very technical but powerful stuff that were not possible. But there's some caveats, obviously. Like this is not going to be something where like we're compiling our JavaScript to WebAssembly, because JavaScript is such a loose language. It's so dynamic that while you could theoretically do it, you would not want to. Like the performance would be significantly less than what a browser engine can give you by default, and you'd be re-implementing a lot of the you'd be re-implementing all the optimizations that a browser has, by default. Because you'd have to ship, if you wanted to, you could ship your own interpreter, but most likely you'd probably ship your own JIT, which again doesn't make any sense because a browser already has one. So it's not a replacement for JavaScript. Like you're not going to target. It's a replacement for JavaScript in the cases where it didn't really make sense for us to be compiling to JavaScript in the first place. It was just the only option, and so it's just opening up a lot of possibilities, and a lot of us are really excited about it, as you can probably tell.
All right. Well, next beginner question would be, can I access the DOM with it? Like, how would I use this? Where would I use it?
Yeah, Sean, I know I've talked a lot, so.
Yes. So currently, you don't have the ability to access the DOM APIs or any of the web APIs through WebAssembly. But the current, I guess it's spec amendment, I think is what they call it. I don't know the official terminology for the community and working groups, but have discussed a feature called JavaScript Bindings, which will allow for a If you think of how WebAssembly module will be shipped, it'll be like this module binary, but on each side, so like facing inward to the binary code itself, as well as to the JavaScript world, there'll be these two very thin layers of JavaScript that will help pass information as well as call different APIs native to the browser from WebAssembly. And so I think Luke Wagner, who's on the community group, also likes to call this the WASM burger, where you have these two JavaScript buttons and then the binary itself. And so that's kind of this interoperable layer. And I think that's being worked on right now and kind of midway through the implementation or kind of like specification process.
And just to clarify that one, it's not that you can't call into JavaScript. I think you're referring to, Sean, natively calling the DOM API without using, because right now you can call the DOM APIs, but it's indirectly. You'd have to, in JavaScript, you expose them to WebAssembly. And so you can totally do it. But one of the problems is that WebAssembly has currently no concept of like an object. It is purely you're passing around numbers, and there's no concept of a struct or a garbage collector or anything like that. And that's a problem because even if they give that ability, if let's say you pass a DOM element to WebAssembly, how then will it know? Like the garbage collector has to know that you've now given ownership to it and has to track that reference in a totally separate heap. So things are a little more complicated, and that's why the proposal that the Sean was talking about was not initially given, like it wasn't included in part of the V1 of the spec, but it's very quickly. Like I've been so surprised how quickly they've been moving in the original spec and then also the new proposals, like lightning fast. This is unprecedented. It's very obvious that the browser vendors they really want all of this, and they're really doing a great job of collaborating and cooperating.
This is kind of a new model for some of these W3C specs, which is doing a community group versus just a single working group. And so JF Bastien, or Jean-François Bastien, is at Apple, and I think he's the chair, but
he is.
He had mentioned that he wanted to do it this way so that the collaboration was much more accessible for the community, and so far it's been really successful. Like I agree, like being able to see all these different features flying left and right, from garbage collection support to shared memory and these JS bindings, it's really neat.
Well, this is really cool, guys. This sounds like a really cool feature. So far what I've gathered is you can program in assembly. There's no garbage collection or any optimizations, and you can't access the DOM. So it sounds really good.
It sounds awful. What's
the sweet spot? What's the sweet spot? So it doesn't have to use Webpack, I hear. So that's good.
Sure. Yeah. You never have to use Webpack again. Just kidding.
No, but what's the sweet spot? What's the good the application for this where it really excels?
Sure. And so initially, very initially, like right now, it excels on basically C or C++. Now you can use Rust experimentally, but it's not. I don't know of anyone who's actually really using it. So for the most part, the initial version is C, C++, and that's just because C and C++ is a really low-level language. It has no garbage collection, doesn't even have normal ref counting compile time ref counting. It has the runtime ref counting, and so it's very, 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 very close to what WebAssembly actually is. It's just basically syntax. It's like one syntactic sugar level up with a very weak type system. And I don't mean that as a negative. I love C++ and I use it a lot, but it is very low level. So that alone already opens up a lot of possibilities. Maybe not for a lot of our listeners, but a lot of people, particularly game programmers, have been waiting for this for the longest time. This because they all write their games in C++, and this has opened up just huge possibilities for them. But that's not really the end goal, right? Like the end goal of this is to also allow almost any language, and a majority of high-level languages require garbage collectors. And that's why the garbage collector proposal that we've been talking about is so important, is because you won't want to ship an entire garbage collector as part of your app. Like, that doesn't make any sense. It would be huge, several hundred megabytes or whatever. And so the browser needs one that works generically. And so it's very important that things are done well. For me personally, Ben, to answer your question, I am excited because I think this is actually going to create basically a whole new renaissance of programming languages that don't even exist today. Languages that are targeted for the web, like Elm. Like, Elm is a great example of what I'm talking about. Like, it was designed for the web, but right now it's compiling to JavaScript. Like, what if it could compile to WebAssembly and be even faster than JavaScript could be, because it's, strongly typed. And I think, Elm's like a very heavy buy-in. But I think languages more like Reason, for example, are a great candidate in the long term to really open up the availability and the experimentation on the web. You don't have to you won't have to write in JavaScript if you don't want to. I don't think JavaScript's going to go anywhere for a very long time, but if ever. But it really just opens up a lot of experimentation. Does that help at all, Ben? Or are there still
No, that's good. I mean, I'm just lobbing softballs at you to see what you say.
Yeah, sure.
I'm
And
nerd
early.
sniping Jay.
Yeah, it's early. Like, right now, like, if you're not writing C++, like, it's not very useful.
I think my concern would be that, like, it's kind of nice that we've kind of settled on, for the most part, a unified language with JavaScript for doing a lot of things. And I think I'd be a little concerned to see, like, the web development community fragmented yet again on a bunch of other languages.
I think that, I think the cool thing is that that's kind of what our job is in preserving kind of that unity. So, like, Webpack, in regards to our story with WebAssembly, is that we want to have WebAssembly modules, which is, they have a module format. It has imports and exports, very similar to ES6 modules. We want to have users be able to use a WebAssembly module or just a C++ file in their project and have it compile to a WASM module and use it just like JavaScript.
But not a CoffeeScript file, right? Though those guys are just the worst.
Technically, right? Well, I mean, technically, you could probably still use it with a CoffeeScript file. I mean,
Okay.
It's not going to compile to WebAssembly.
No, that is correct. So yeah, like, we have a goal of, like, if you wanted to access a WebAssembly module, like, let's say RxJS ships with a separate field called WASM, and but it's the exact same name, all the exports and everything are used the same, then in theory what we want to do is make it so that the user would import RxJS how they would every day in their code, but Webpack would resolve the WASM module instead, but you would use it identical to how you would in your everyday code, except you get all the benefits of WebAssembly. So, like, that's just, I think that allows people, not only WebAssembly to be in the hands of just, like, millions and millions of developers who may never try it if it wasn't, something supported through Webpack, but it also kind of allows kind of the same Precambrian explosion that we've seen in, like, the modules, like these tiny JavaScript modules, or kind of the JavaScript development and growth in the ecosystem.
Yeah, I completely agree with that. That's if all this WebAssembly stuff is just, like, scary to you and you're just like, I'm never going to deal with this. I think, I honestly could bet that within the next maybe year and a half, maybe 2 years max, you might be using a WebAssembly module without really even knowing it. Exactly. Like, maybe you won't even know it. Like, maybe you depend on another project, which then depends on a WebAssembly module, and it's just all transparent to you, and you just, you don't need to know. That's the goal I know that Sean is setting out, and I think it's awesome. Totally.
So in this world, just to clarify for everybody, that we're talking about a world where people have built WebAssembly-based modules that people are using in JavaScript, but that would be dependent on browsers being able to consume those WebAssembly modules, correct?
That's right.
Correct.
Right. So you'd have to have some sort of fallback plan for, well, here's the WebAssembly version of RxJS, and here is the plain Jane version of RxJS, right? The plain JavaScript.
Or even the WASM.js version. A lot of the mscriptum compiler chains will also generate like an WASM.js fallback as well. So like you get like maybe 3 or 4 different tiers of like fallbacks based on, you know, browser or whatnot, and we plan on kind of implementing that ourselves so that is all just implementation details, and you can just be focused on writing your code.
Mm-hmm. And with the focus of the whole evergreen browsers, I think, yes, there's definitely going to be people who are not going to be able to use WebAssembly because for whatever reason, it's just the fallbacks are infeasible, because obviously WebAssembly has things that WASM.js does not have. And WASM.js, by the way, for people who don't know, it's basically a subset of JavaScript that was experimented with and led by Mozilla for a number of years to try and basically create a compilation target that was would easily fall back, because every browser could basically parse and run this. It just wouldn't be as fast as if it were this typed WASM file. But the problem is it's still a text-based file, and it still has a very verbose representation, and so the files are just massive. And you can't represent things like 64-bit floats, and you can't do multi-threading, and like all things that basically WASM needed to do. It figured out fairly quickly that WASM.js was not going to solve the problems they needed. So like I was saying, there's definitely going to be people who are not able to use this, and that's cool for quite a long time, and that's totally cool. But the web has to, I think, just because people aren't able to use it now doesn't mean that we shouldn't be excited, shouldn't be investing in this, because we're really investing in our future. Eventually, those browsers will go away, and it'll be only the browsers that have the support for WebAssembly. So, and all the modern browsers today are going to implement it. All of them, Chrome and Firefox have already shipped it. Safari, did they ship it recently? I know they have it done, but I don't know if they shipped it yet. Edge, I know for a fact, is not yet shipped, but it's going to be shipped as part of their new Windows update, which I think is in the next month or so. Sean could probably speak to that.
Yeah, no, absolutely. I think it's what we call RS3 or RS4. So yeah, we should see it in a couple months.
Okay, yeah. So it's already ready and pretty solid. So basically, all the major browsers that are evergreen are going to continue to update with this. So I'm pretty excited.
Yeah, and I mean, it's like, for me, it's like I don't really come from a background of strong type languages or strict static type languages, so. It's been kind of fun experimenting with things like Rust, and after using it, it's like, wow, I would love to even just use this in a project for the web to do, computationally expensive things. So I'm really excited to get the work started, from our side at Webpack, and we open up a lot of opportunities also by doing this work, and so we're pretty stoked.
Yeah, and a lot of people. One thing I wanted to talk about was some misconceptions that people have about WebAssembly, or questions that I really commonly get. For example, one of the first ones I get is almost always is, why didn't they just use the JVM? Like, isn't this Java applets all over again? And they're not entirely, like, it's not an entirely incorrect question. Like, certainly in a perfect world, using something that already exists and is super stable and prolific, why wouldn't we just use that? But there are a number of just things that are just very incompatible with the JVM, like even fundamental things, for like example, the copyright stuff, with Oracle and all of the problems that Google has been experiencing with Android and all that stuff. And even if you got all past that, which I don't think you could, the JVM was really designed for Java. Like, it is a Java bytecode. And yeah, there are other languages. There's tons of languages that compile down to it, but it's kind of a similar situation to like compiling to JavaScript. Like, it's kind of forcing it into this model, and it's just not a great target for things like C and C++ or some of the other things that we want to do. And it has totally different goals as well. The file size is not nearly as small as what WebAssembly is. Like, there's just incompatible goals. And there are other similar virtual machine stuff. There's Llvm Ir with the whole PNACL stuff and the CLR from Microsoft. And again, they're all kind of basically the same problems. The goals of them are totally different and incompatible. Sorry, say it again, Tracy.
Can I just have one question, just back to ASM.js really quickly?
Uh-huh.
So is ASM.js what they built the Unreal Engine games with a few years ago?
So the Unreal Engine is written in mostly C and C++, mostly C++. And so they compile it using a tool chain called Emscripten that's been around for a number of years. And they compile that C++ to ASM.js. And they did that many years ago as like a proof of concept. But then as part of doing that proof of concept, not that particular one, but just in general, they discovered that ASM.js is just not going to be long-term the best target. And that's why they started working on WebAssembly, is to fix some of the shortcomings of ASM.js. So ASM.js really is, for the most part, I don't know what their Mozilla's official stance is, but from what I gather, they're not really investing more into ASM. Like really WebAssembly and JavaScript are the two things that they're going to continue investing in. And ASM is great as kind of a fallback for the existing WASM stuff, assuming you don't use some of the new WASM features that can't be falled back. Like, they could polyfill them, but they're going to perform pretty poorly compared to WASM. So I don't know if that answers your question. So they don't actually write it in ASM. They compile it to that. It's a compilation target. Does that make sense?
Yeah. And then another thing, every time I talk to people about WebAssembly, I always, my vision is that you can just take take any mobile app game and all of a sudden it appears on the web with WebAssembly. Mm-hmm. When is that going to happen? Sean's like, it's going to happen.
It totally depends. Like it depends on what they wrote, what language they wrote it in, what libraries they use. Do they rely on system APIs? There's complicated apps have a lot of they may have the compatibility as far as a binary level goes, but the APIs that are actually compiled in those binaries don't exist. So you could take a game that, like you were saying, let's say it was written for iOS, and it used very specific APIs that are only available on iOS devices. And you could compile that to WebAssembly. But the problem is when you ran it in WebAssembly, you'd get a bunch of link time errors, basically saying all of these symbols, all of these things that they were expecting just don't exist. The browser does not expose these APIs that it relied on. And certainly you could then provide polyfills for those APIs. And that's in some ways what Emscripten does. It provides the C standard library, and it emulates signals and all sorts of other, operating system expected stuff like file system stuff. And, it abstracts all that stuff away for you. And you could write something similar to that, but it's probably, for the average person, it's not going to be trivial to compile to WebAssembly, but it certainly is a lot easier than rewriting your entire app. And that's the end goal. Especially if you're writing a new game, then you can ahead of time. I want to target this for iOS and Android and the web, on WebAssembly, and then you can do it.
Oh, I really like that.
You can do it from the start. You can write it in C++, and you have your preprocessor directives to import this or import that depending on what platform I'm on. Macros and you can do all of that ahead of time instead of doing it from the previous. But the Unreal Engine is just a great example. I don't imagine they had to do a ton of work to make that compile and work in WebAssembly, but I really don't know.
Yeah, and I think I was just so our team or the core team was just talking with the V8 team about some things with WebAssembly last week, and Brad Green, who's kind of the lead on the project, kind of describes it like the C++ has an embarrassing set of build tools and possibilities, which we all kind of jokingly were like, yeah, we can relate. But yeah, so like there's a lot of different nuance between different libraries and how things can be built. A lot of knobs, a lot of levers, and so like it's really not standard across the board whatsoever. So like you might even start to see the way that people are creating new content or like that's publishing new modules that are meant to be, compiled for WebAssembly, may even take on a different shape and structure and format.
But will I ever be able to use WebAssembly to execute a JavaScript function on a different thread?
Yeah, you will definitely be able to introduce concurrency into JavaScript. like through WebAssembly, you can create race conditions in JavaScript, which is wild and dangerous. But so far at least it's not available now. But like based on the current thread proposal, you're gonna be able to do that. Like,
all right, that's good. I want to know when I can do that because I want to up my threat level. That's what I want.
When you can also use like good APIs to help protect you from these things, like shared array buffer with atomics. So, like primitives for having like mutex and stuff like that on accessing references that might be shared across threads.
Mm-hmm. And you're still not going to be able to block on the main thread, like even in WebAssembly. So if you want blocking, you're gonna have to have like a master thread that then spawns other threads. A lot like iOS apps. I don't know about other ones, but a lot of the iOS stuff, they don't run the UI on the main thread.
That's interesting. Yeah, because I was wondering things like if I could use it, say in RxJS, to some effect where if I could statically analyze ahead of time and know that I'm only dealing with constants inside of some function body, if I could then run those things in parallel if possible. But yeah, it sounds like not yet, but eventually.
Not yet.
You can do that with like Rust and Neon bindings. I mean, that's kind of like the step in between Rust and WebAssembly right now is where Dave Herman made this like bindings library to create native node modules. And I think there's a library in Rust called Rayon, which allows you to do something similar.
Yeah, but when you say node, aren't we using IO.js now? I'm kidding. I'm so kidding.
Wow,
don't ever do that.
You're so 2014, Tracy.
Don't. No, it's AO.js.
AO.js. All right, sounds like a song. With Node. Yeah, with Node you can do whatever you want. Like you could write an extension that just does awful things because it's native. You can do whatever you want.
That's right.
So what about the things related to Sean WebAssembly and the recent grant you guys got?
Yeah. Go ahead.
Is that related to what's going on with WebAssembly and what you guys will be doing?
Yeah, absolutely. So maybe about 6 months ago, maybe even longer, I can't remember. I started talking with Yehuda Katz about like WebAssembly and modules, and he was like, "Here, talk to Dave Herman, man. You might find some interesting stuff about what they're doing over at Mozilla." And so, long story short, we decided like, wow, this would be really cool if it was super easy to get rid of all the boilerplate involved with a usual or like an everyday developer or even a seasoned developer writing WebAssembly and having to compile it with the browser APIs. So I don't know, call it a strategic play, call it whatever you want. But knowing that Mozilla was, this is kind of like a very key feature for them, and it's a key feature for all the browsers. We decided to look for grant funding and saw that the Mozilla open source support, I think it's the board or something for Mozilla, we decided to submit a grant to them for implementing WebAssembly as a first-class citizen in Webpack. And so, right now in Webpack, kind of probably one of the most hacky things that people might mention is that really only JavaScript is a first-class citizen. So if you want to resolve modules, it's using the Node.js resolution algorithm. If you want to load CSS and JS, but you want to have a CSS bundle, it has to be extracted out, and there really isn't a runtime, and you can't really lazy load it. And so those are kind of those side effects of only having one type of module or one type of file as being a first-class citizen in Webpack. And so this still, WebAssembly modules have a custom runtime. They can be parsed, and they have special loading needs and things like that. And so we were like, wow, this could open up an opportunity for us to not only have WebAssembly be just supported out of the box, but we can expand the architecture so that other people can implement CSS as a first-class citizen, HTML as a first-class citizen. And so, yeah, we submitted a grant, and, thanks to, the help of Lynn Clark and Luke Wagner and a bunch of other people involved with us along the way, we got the grant approved and accepted. And so we got awarded $125,000 to implement it, I think, over a year and a half time.
That's awesome. That's really exciting.
Yeah, we're pretty stoked because it's like it's not only something that's going to help benefit the browsers, it's something that benefits users, game engineers, but it's also like we're getting funded for work to even improve our architecture. And so like that was super exciting to me because it's like finding something that really helps kill like 5 birds with one stone is pretty powerful.
Mm-hmm.
I'm calling PETA.
Yeah. Stop killing birds, Sean.
Catching birds.
Well,
yeah, there you go.
We have about 8 or 10 minutes left. So Jay, do you want to finish off with anything interesting, or Ben, do you have any follow-up questions? Or
No. This whole time I've just been waiting for my Webpack to get done, so I'm good.
You didn't know how to use Webpack, Ben.
That's why it's taking so long.
Oh, okay. All right.
Yeah. Yeah, I would encourage, like, if you already know C or C++, I think I would encourage you right now to go to webassembly.org and take a look at the Getting Started, which will run you through like using mscriptin. But there's a whole bunch of other tools, Binarian, Wabbit. There's just a whole bunch. Oh yeah. There's a bunch of tools that exist, and so you can like Llvm. Which it's too hard to explain. It's basically it's a God, how do you explain what Llvm is? It basically generates the actual different targets for all the different machines, like when you're compiling from other languages like C, C++. It's a project that the compiler will use to generate the target code, like the x86 code or the.
What does Llvm actually stand for? Was it funded in part by LL Cool J by any chance?
Low-level virtual machine, I think.
Oh.
That's correct.
Yeah, and it's not it is a virtual machine, but it's not like a virtual machine like everyone else is used to. Like, it's not for running code. It's the same point. Like, it will generate instructions for a target.
Given compiler, right?
Yeah, exactly. It's static, and so it's like given Llvm IR, like this intermediate format, it will then spit out the target format. Like a normal virtual machine, like you're used to, would do, but it just doesn't run it. So there's a lot of tooling stuff. If you're not into that stuff, just know that other things are coming very quickly. If you are an Elm person, you can get in on the discussion today and talk to the Elm people about their WASM plans, which they do have plans, and they've been talking about it. You can talk to the Webpack people. You can talk to Sean and see how you can get involved. And you don't have to be like this big compiler nut or know how binary assembly stuff works. Like, you can get your foot in the door, or even just discuss from a user standpoint. Like, those type of things are even helpful. Like, on the Webpack side of things, like Sean was saying, the end goal is you don't need to know anything about WebAssembly. Like you have your loader, and you have your C++ code or your Elm code or what have you, and it just works. It just it does all the compilation for you, and you just don't have to know anything about that. We're not there yet, but as we incrementally get there, we need lots of people to be trying these things and giving feedback and stuff like that.
Basically breaking everything.
Yes. Break everything.
Break all the things.
And you can get involved, like Sean was mentioning earlier, you can get involved in the spec process. They're very open and transparent.
Yes. Talk to your company and say, ask them to send you to the WASM community group. It's part of the W3C, so if your organization is, or if you'd like to come and join as an expert or an invited guest, you can always reach out to JF Bastian or even myself, and I can forward you to him. I went for the first time because I wanted to present what our plans were for Webpack. But now, I'm actually really excited to continue to be involved in the process because, even these working groups and community groups need people who represent, just how developers want to see things from their side. And a lot of the people involved in this process maybe have never written, a web app in their entire life. And so, being able to provide perspective can be really powerful.
Yeah, that's really important. Like, Sean's completely true. Like, it's not a knock on them. They're compiler people, that through and through. That's what they do. And so they're going to make the best compiler related decisions, the decisions that we mere mortals, can't make. But sometimes the decisions they make may seem arbitrary to them, but are critical to us, like impact us just tremendously. And so we need both. We need people like us, people like you listening, and people like the compiler guys, like JFS.
A good example is like I mentioned. We want this, for like through loaders, and loaders are kind of this per file incremental based compilation process, and so like. Does Llvm have incremental support, or for these types of languages? And they're all like, I think that's something that they never have to think about, because when they build C++ and compile it, it's always one single pass. But on the web, it's totally different. The tooling and everything, and so even just the littlest detail may be really insightful.
That's how I feel about the RxJS docs. when I asked Jay a question, I'm like, Jay, did you know that this was there? He's like, I just read the source code, Tracy.
How do the color beads work? Let me see this.
Yeah, the marble.
The color beads.
I've never heard color beads better.
You still have those? Yeah, the gumdrops.
Parts marbles.
Marbles.
So, where can we find more information?
Yes, so I would say take a look at, there's two resources. One is going to be on our Medium publication. So if you go to medium.com/webpack, you can find, I think it's under announcements, the WebAssembly article that we announced the grant. And that not only has kind of a great overview of what we're trying to accomplish and what we ask from the community, but also you can go to our GitHub, and in our issue list under webpack/webpack, so github.com/webpack/webpack, you can take a look at the issue label WebAssembly. And so that'll have all the issues that we've had planned out for the milestones that we have for our grant. And they're kind of high level for right now, but I'm hoping to continue to flesh them out, as there's already language and like people from the Rust community and the C++ community are like, hey, can we start helping you with loaders and things like that? So there's never feel free to ask a question or clarification or advice or direction on any of them.
And then Jay, what are your thoughts on just getting more information about WebAssembly? Which, by the way, why are you not at those meetings?
I am not at those meetings. It's
because they're so boring.
No, it's complicated. So I work at Netflix, and we're on the W3C. And so if I go to those meetings, I'm officially representing Netflix.
Correct.
And so anything I say is like representing Netflix. And so I could accidentally give them permission to use things that they shouldn't be able to use. Like, it's just basically technicalities. I don't do WASM as part of my full-time job here. And because of that, they don't, they didn't tell me not to do it, but they basically said be very, 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 very careful that you don't give up anything on accident, like unknowingly give permission, which I totally could accidentally do. So I decided independently that I'm just not going to go because, and I would just, just discuss online and on GitHub and stuff like that, but not go to the meeting so that I don't accidentally put myself in a situation, a legal.
Hey, Sean, what are those birds that you raised in Nebraska again? What were those called?
The actual
Chickens?
Breeds or the animal itself? It's called a hen
Chad,
or chicken.
Are you calling me a
Oh, that was unrelated. I'm sorry, Jay.
Oh, I was like, are you
Unrelated.
calling me a chicken?
I was just kidding.
No, I would never do that.
Yeah, I don't like lawyers. I don't like getting involved with the whole lawyers thing. But Tracy, actually, you've been involved, and I've been meaning to bug you to get more involved because we wrote that Baylang compiler. Like I was teaching Tracy about WebAssembly, and she got it. Yeah, Baylang.
Wait, is it
Yes.
GAE Lang?
Yes.
Oh my gosh, that's awesome.
Yeah, I gave Tracy like a 3-hour crash course on compilers, and she did a great job following along. Like I don't know how. When I was first learning about compilers, it took me forever to get things.
What kind of language is
so nice.
Baylang?
Yeah, that's what it is. That's why. It's because
It basically said Bay is J, J is Bay.
Oh yeah,
Bay is Bay.
That's how you assign variables. Is you're just like
static or dynamically typed.
dynamic. It didn't matter. There was no. It didn't need to be typed.
So then more importantly, will there be a webpack loader for it? Can we add that?
Yeah, absolutely.
There you go. Pairing session. I'll just set you up, Tracy.
Boom.
You guys are so funny. Yeah, I don't know how I could get more involved. I need to fix these docs first, the RxJS docs. Project number 1.
That's true. That is priority number 1.
Yeah, project number 2, WebAssembly. Maybe I could basically just like have you in my ear, and then you could be listening, and then you could be like, Tracy, ask these questions. And then that way it's not really you, it's me asking these questions, And then lawyers, it'll be fine. I'm representing the Baylang.
That would be great. Sounds like a movie plot.
Yeah. Well, anyways, I thought this was a great conversation, and I'm so glad there's more interesting stuff related to WebAssembly. I think most of the conferences that I've been to and the WebAssembly talks I've been giving, which I know, Jay, you're giving a WebAssembly talk at QCon soon, but most of the conversations related to it is, okay, WebAssembly is cool, we want to hear about it, but it doesn't seem like it's there yet. So I think most speakers are saying like, hey, this is awesome, but then I think in practice most people don't really understand how they can use it. And I think part of that is also because where it's, where at least we see people getting excited, but where I see people getting excited about it are at JavaScript focused conferences. And so it sounds like we need to get more in those like C or .NET related conferences and get those people excited about WebAssembly so we can start seeing some movement there.
Yeah, it's going to be weird, like cross-pollination of communities. Like it's opening up so many.
The weird thing for RxJS is that RxJS was actually born out of an attempt to make C# compile to JavaScript. Right?
Lol.
So now it was the only part of that lived. It was Microsoft's Project Volta, and that's where the logo even came from. And now we're looking at C# would probably. I'm assuming Microsoft will do this because this seems like a very Microsofty thing to do. Would be have C# compile to WebAssembly, but
who says it's not already done?
All right. Well, very good.
That's official. I'm tweeting it.
Oh, it's not done
On
yet.
the
But you can ask Scott Hanselman about it, and he'll be happy to talk to you. There's lots of awesome stuff we have planned. But
I love C#. I think that'd be cool.
All right, y'all. Well, I'll talk to you all soon. Thank you for listening to this episode of Modern Web, and we'll see you on the next episode.
Bye.
Deuces.
Thanks for listening. To find more podcasts, videos, and online conferences, check out modern-web.org.